I'm going to start by showing the equipment that I'm using here. And I have a drawing board about, let's see, what size is that? It's about 30 by 20 by 30, or 24 by 30. And I'm using a fairly new, I don't know if you could see this since it's transparent, 30-60 triangle and a 45-degree triangle. It's kind of old and beat up. I also have, I'm using a T-square. And by the way, the drawing board is one with a metal edge, which is really handy because the T-square will be true when it goes up and down on the board. So I like that kind of board. If you do buy one of these boards, it's a good idea to make sure you look at that edge and make sure it's straight. I know sometimes I've bought some at art stores that aren't straight. Okay, I also use a see-through ruler, which is the B85 see-through ruler. See-through is a brand name. B85 is the style I use, 1 inch with little half-inch heavy marks and then 1/8 marks on it in red. This is really good. I like to be able to see through it and to make sure things are parallel by referring to those marks. Now and then I'll do things in scale. So I have here an architect's scale. It's important if you're going to buy one of these that you look carefully at it and make sure that it says architect on it. There's a scale called an engineer scale that looks identical to this when you first look at it. So be sure you're buying an architect scale if you plan to buy one. I also will be using, I think I'll be using various pencils. I'm going to use a lead holder with 2H lead, I think, for some of the drawings I'm doing here. I'm using one of the old pencil pointers. Looks kind of like this. There's the new blue ones now, the new small ones that are pretty handy. This one is not so good because it uses sandpaper, and eventually that gets filled up and clogged. But the new ones are good, the new little blue ones. But I kind of like this old one, so I use that. Okay, what I wanted to start out with is doing some, just a rough sketch here that shows what I think is a good layout or a good image that we can use to define or to define the definitions, let's say it that way, defining definitions, all right? So here, I'm going to start with a drawing that shows initially what I call a picture plane. So I'm making a vertical line here, and then in perspective, a kind of a rectangle sitting upright like this. Now, then I have here a ground plane, another rectangle drawn in this direction here, laying flat on the ground. So what I want to show here is how we can define some of these things. Although we define this as a picture plane, pardon my crummy lettering here, plane, and down here is the ground plane. What we need to know about these surfaces is that these are only representing an infinite plane. The picture plane is a rectangle that sits upright, and that represents an infinite plane. It goes on beyond the rectangle. The ground plane also goes on beyond this. So what I'm going to do up here is I'm going to draw a line which I'll call a horizon line. Now the definition that I had, I'm going to read this here, the definition I had as a student was, if I can find the, oh yeah, horizon line or eye level line. Now this is a very complicated definition. It says the distance the eye is above the ground is always indicated on the picture plane by a horizontal line the same distance above the ground as the station point. Well, all that's really saying is the horizon line is at the viewer's eye level. And that's all we need to know. So I'm going to write here horizon line, and I'm going to write below it eye level. It's the viewer's eye level. Not the eye level of the people in the scene, but the viewer's eye level. So that's my pencil sharpener grinding over there. Then what I'm going to do here is locate, I'm going to draw a line that comes out like this that doesn't have any definition at all. But if I make a vertical up here, this point right here and this line is called a distance line. It's a line from the viewer, from the eye of the viewer to the center of vision on the picture plane. So this point right here is the center of vision. This point right here, the eye of the viewer, is called the station point. Station point. Now, you'll see that usually shown two different ways in a drawing like this. You'll see it down here too. So if I take just a dashed line down like this, it shows that I'm kind of taking this distance line right here and folding it down so that I can draw it on the paper. This works just fine for plotting in perspective. We can fold the distance line down right onto the paper. And in so doing, we can also locate down here the station point. Okay, so what we've defined so far is a horizon line, which is known as the eye level line. And we have the center of vision, which is a point on the picture plane opposite the observer's eye. The observer's eye is called the station point. So we've covered station point, horizon line, distance line, picture plane, center of vision, the ground line. Okay, that's the place where the picture plane intersects the ground plane. Right here is called a ground line. It can also be used as a measuring line. So we might call it horizontal measuring line. Horizontal measuring line. Let's see, we all, I think, pretty much know what a vanishing point is. I can define that here a little bit more clearly in another drawing. There's also something called a true height line, and I usually put it on the ground line right here and draw it right up through here like this. This would be the true height line. True height line. The measurement of the height of any object in the scene can be plotted from that line. All right, we have another definition here that is, it sounds inane, and it's a little bit hard to imagine what it's talking about. But when I illustrate pretty soon how it works, I think it will become clear. It's called a measuring point. And the definition is, a measuring point is a point on the horizon line that is the same distance from the vanishing point that the station point is from the vanishing point. Measurements are made by drawing lines from points on the ground line to the measuring point. I know that sounds a little hard to understand, but I think when I define it a little bit later, we'll see what it means. All right, so we have a figure standing here looking at a picture plane. We have the distance from his eye directly into the picture plane. The distance line is always perpendicular to the surface of the picture plane. So as a person turns their head and looks from side to side, that distance line will also turn, and the picture plane will turn also, remaining perpendicular to that distance line. Okay, there's one other thing that I think I might be able to illustrate here too, and that is what we call the cone of vision. That's the area that can be seen and drawn without distortion. It's usually within 60 degrees at the eye. So if I were to draw a line going away from the eye at this angle, imagine that as a 30-degree angle here, and imagine another 30-degree angle going over here. What we have then are the two sides of the cone of vision. This is another 30-degree angle here. Now, that's the end of the cone of vision, which would be seen as an ellipse. The end of the cone would be seen as an ellipse, looking something like this. That's a little distorted here, but that's okay. So the total angle between left and right here would be 60 degrees. So what we should know here about this is that the center of vision is the only place where there's really true perspective. The farther and farther you get away from the center of vision, the more and more distortion there is. So somebody has decided 60 degrees is just about good enough. That looks good enough. So as you get out toward the edge of the 60 degrees, you may begin to experience a little distortion in your drawing. But like I say, the truer and truer perspective is right in the center here.